So we're graphing linear functions, where a linear function is a function where the highest power of x is a 1. So just x, yeah, because we never really write the 1 there, do we? And we realize if we graph a linear function, it will always be a line, yeah? So a straight line, if you like, yeah? It's always going to be a line, okay? Because we also realize that we have quadratic functions, yeah, which is a curve like this. Cubic functions, where the highest power of x is a 3, which is like, I don't know, like some sort of S figure, or something that looks like an S. Okay, but linear functions, a straight line. Good. Now, in my previous video, I showed you how many points do you need to draw a line. Well, you only need 2 points, yeah? But we always find 3 just to make sure we didn't make a silly mistake. And we're going to start with the most basic line you can get, y equals x. So I drew it here, so I'm going to make my table of values. I'm just going to take this one away, otherwise the ink will be there as well. And I call that table of value a fishbone table, okay, but you can forget that word. It just looks like a dead fish, okay, so that's why I call it. So whenever I talk about a fishbone table, this is what I mean. And I can choose 3 values for x, doesn't matter what, yeah, but don't take 1,000, because as I showed you in the previous video, I can't grab 1,000 because my skill is not set appropriately then, yeah? But let's say x is 1. How much is y when x is 1? Y equals x, so now I'm substituting that value for x, so it's going to say y equals 1. And I'm going to choose a different number for x, let's say 2, and then it's going to say y equals 2, yeah, because I substitute my chosen value for x, so y equals 2. What shall we do? Y or x equals, let's say, minus 1, and that's going to say y equals x, or y equals minus 1. Good, I'm going to plot my 3 points, 1, 1, 2, 2, minus 1, minus 1. And if all 3 are on one line, and they are, then I know I didn't make a silly mistake. Yeah, perhaps that 3rd point was somewhere else, then I just got to check, did I plot it correctly, or did I make a mistake with finding my values, or whatever. Yeah, but if they're all 3 on one line, then I know that is correct. And this is the most basic line you can get. There we go. Y equals x, yeah, which is a line through the origin. Okay, and when x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. Okay, you've got to make sure to do this with a sharp pencil, and of course you always use a ruler, okay, because accuracy is important. Now, I try to be as accurate as I can with these markers, by the way. Moving on, y equals 2x. So y equals 2 times x. If I want to graph that, I need to create a table of values, yeah, a fishbone table. 3 points, yeah, a linear function, I need 3 points. Let's say x is 0, okay? I'm going to substitute that value in my equation, in my function. So y equals 2 times x, so 2 times 0, and that is 0. Let's say x is 1, I'm going a little bit quicker now. So y is 2 times x, or 2 times 1, so that is 2. And let's say I pick for x is 2, it's going to say y equals 2 times 2, and that is 4. So I've got my 3 points. Now let's see if if they are all on one line. I should say 0, 0, 0, 0. The other point I chose was 1, 2, 1, 2, and 2, 4. Okay. And then I check, and indeed they are on one line, and I draw a nice confident long line like that. I do not stop at the origin. There we go. And I should have told you, label your lines please, which means just write down the equation next to it. Y equals 2x, can you read that? And this one, y equals x. So everybody understands which line belongs to which linear equation. And what do you see when you compare those 2 lines? What do you notice? Well, you can notice, first of all, they both go through the origin. Yeah, that is something they have in common. But what is different? Well, that second line is steeper, isn't it? That second line is steeper. Yeah? So they both go through the origin, but that second line, the line y equals 2x, is steeper. Okay, that is important for later, okay, but I already want to have told you that. Last one, I'm going to go relatively quickly. 2x plus 1. 2x plus 1, table of values. I need 3 points. let's say 0, 2 times 0 is 0 plus 1 is 1. Let's say I pick the point 1, 2 times 1 is 2 plus 1 is 3. And let's say I pick minus 1, 2 times minus 1 is minus 2 plus 1 is minus 1. And I'll plot those 3 points, 0, 1. There, I'll do that in green, otherwise I have too much in red there. Well, I'll do it in blue. 0, 1, 1, 3, minus 1, minus 1. Yeah, are they all on one line? Let me check that. Yes, they are. So I didn't make a silly mistake. And I'll graph that with my sharp pencil and my ruler, and I'll label it by writing down the equation next to it so everybody understands which line it is. And then again, what do I notice when I look at the blue line? Well, the blue line doesn't go through the origin anymore. No, it goes through the point y is 1. Okay, while the other two lines went through the point where y is 0. Okay, and the second thing I notice is that this second line, y equals 2x, is parallel, is equally as steep as the line y equals 2x plus 1. Now in future videos when we're doing coordinate geometry, yeah, I will explain that in more detail, yeah, but hopefully you notice that the steepness of a line is somehow given by that number in front of your x, and where it cuts the y-x, where the line cuts the y-x is somehow given by that number there at the end of the function. Okay, moving on to the next video, guys. I have more linear functions for you, like these for you, and so more practice for you there. So next video, and I'll see you there. Bye bye.